Good morning, everyone. Today we are going to study environmental engineering subject. Now, before we study this subject or before knowing about this subject, first of all, we have to know what is the importance of environmental engineering in GATE exam. Now, you are already having the knowledge of weightage of each subject. Let us suppose we are considering this subject on the basis of their weightage. The first subject which is very important from the examination point of view or from the GATE point of view is geotechnical engineering. Now, what is the weightage of geotechnical engineering in GATE exam? Its weightage is almost 16 marks. That is the approximate weightage. Okay. We will consider shift 1 and shift 2, and based on the average data of both the shift, we have considered the weightage as 16 marks. That is one of the most important subject from the civil engineering point of view. Now, if we are talking about the second most important subject, that is the transportation engineering. Now, what is the weightage of transportation engineering in GATE exam? Its weightage is 14 marks. And now the third most important subject from the GATE point of view and from the consideration of civil engineering is environmental engineering. And its weightage is 12 marks. Now, if we will skip any of the subject from these three, then it is very difficult to crack the GATE exam, as well as it is very difficult to get a very good rank in GATE exam. So we have to at least study these three subjects with utmost care. Okay. Now we will see what are the basic chapters which we will cover in this subject, that is the environmental engineering. Now the first one is water supply. If we are talking about the drinking water, now, first we have to determine what is the source of this drinking water, that is river, lake, pond, etc. Okay. Now, after finding the source, we have to find out the demand of this water. After finding the demand, we have to find out the quality of this water. Now, if the quality is within the permissible range, then it is very good for drinking purpose. And if it is not, then we have to treat that water, because we know that the drinking water which is available on the earth is only 2%. So we have to treat that water. We don't have any other choice, but we have to treat that water. Now, what are the treatment processes? We have various treatment processes such as screening, sedimentation tank, okay, secondary sedimentation tank with coagulation and flocculation, filtration, after that disinfection, and after that softening. So we have to treat that water. After treating that water, we have to supply that water to various households with the help of distribution network. Now, all this process is covered in the first chapter, that is the water supply, which comprises of the 60% of the overall subject. And the number of questions which is asked from this portion is 52 questions in the last 10 years, and its weightage is almost 88 marks. So if we want to study environmental engineering in a very good manner, then we have to cover the water supply portion with utmost care. Okay. Now the second one is wastewater. Now the water which is coming from the human solid waste as well as from the industrial waste comprises the wastewater. Now we have to again find out the characteristic of this wastewater, as well as we have to treat that water. Now why we are treating this wastewater? Because we want to directly dispose this wastewater in the river. So we have to at least do the primary and secondary treatment of this wastewater. Now the question which had been asked from this wastewater in the last 10 years is 30 questions, and the weightage of this is 49 marks. Now the next, which is the most important portion from the environmental engineering in the recent papers, is the municipal solid waste. Now, municipal solid waste comprises of almost 16% of the environmental engineering, that is 16 marks. So, in the recent papers, this particular portion had become very famous. So, we have to study this portion also. Now, I had written here the air and noise pollution, but in GATE exam, only air pollution is there. We don't have to consider the noise pollution, because when the IIT Bombay had conducted the GATE paper, they had changed the syllabus, and now only the air pollution is there in the GATE syllabus. So the weightage of air pollution is also very high in the GATE exam. Almost 32 marks question had been asked from these two portions. Now, if we consider only the air pollution, then its weightage is almost 20 to 22 marks in the GATE exam. Okay, students. Now, if we want to see the year-wise weightage of environmental engineering, in 2024, 10 marks question had been asked from this portion, okay, and that is the average weightage of both the shifts. Similarly, in 2023, 12 marks question had been asked. In 2022, 11 marks. In 2021, 12 marks. So, we can say that averagely, the marks which is covered from this portion is 10 to 12 marks, which is very important from the GATE point of view, because you all are aware about that if you will lose only 1 marks, that will cost almost 250 rank. Okay, so that is the importance of 1 marks in GATE exam. Okay, students, now students, we are going to cover these portion in the water supply engineering, which we had already discussed. That is the sources of water and water demand. Second one is quality control of water supply. Third one is treatment of water, and the last one is distribution system. Now, students, we had already seen the sources of water as well as water demand, population forecasting, and the quality characteristic of water. Now, if we have to treat that water, then what are the various processes in the treatment of water we are going to discuss today. So, students, the entire treatment process is shown on your screen, which starts from the screening portion. Now, in the screening portion, we will remove the floating matters. In floating matters, we will cover the human dead bodies as well as animal dead bodies, trees, plants, plastics, etc. We will remove that in the screening process. Okay. Now, I am already discussing the outline of this method. We will discuss one by one each and every process in detail, starting from the screening portion. Now, students, if the water is very polluted, such as the color of that water is very dark, smell is coming out from that water, as well as the taste of water is not very good, then we have to do the aeration process before the plain sedimentation process. Okay, and if the water is not highly polluted, then we can do the aeration process in the second last process of the treatment unit. Okay, now what we are going to do in the aeration process, we will add the oxygen. We will add the oxygen to remove the odor, taste, as well as color from the water supply. Okay, now what is plain sedimentation, or why we are going to do the plain sedimentation process? Now, students, you all are aware about from where we are taking that water. We are taking that water for drinking purpose from the rivers, ponds, lakes, etc. So there is very high chances that the grit particle is also there in that water. Now, grit particle means large size stone. Now, if the large size stone is there, then we have to remove that. Okay. Now, how we will remove that? We will remove that in the plain sedimentation tank. Now, the entire process we are going to discuss today only. Now, after the removal of heavy grit particle, if very finer, smaller particle is also present in that water, then it will not be removed with the help of plain sedimentation tank. We have to do other efforts to remove that smaller or very finer grit particles, and for that we had the other treatment unit, that is the sedimentation aided with coagulation and flocculation. When we will remove the very finer impurities from the water, then we have the other treatment unit. That is the filtration process. Now, what we are going to remove in the filtration process? The first one is very smaller grit particle, which will remain there in that water after the sedimentation aided with coagulation and flocculation process, and the percentage of that particle is very small. Okay, now we will remove some amount of organic matter also there. Okay, now the water pass through the next process, which is known as disinfection. Now, in the disinfection process, we will remove the remaining organic matter as well as the micro. Now, after disinfection unit, we have to do the aeration process if we had not done that in the starting. And if we had already done the aeration process in the second process of the treatment unit, then we will skip that aeration process from here and directly we have to do the softening process of that water. Now in the softening process, what we are going to remove? We are going to remove the hardness of that water. Okay, students. Now we will discuss one by one each and every unit in detail, starting from the screening portion. Students, I had shown one video here so that you will get a clear idea about how the screening process works. So you will watch this video once. After it, I will discuss this whole concept in detail with you. Okay. Now from this particular portion, water is coming out and we had installed the screen on this side. Okay. Now the impurities which is present in this water gets clogged or gets removed from this portion, that is the spacing between the screens. Okay. Now we will see the animated view of the screening process. Okay. Now in this animated view, all the impurities get attached on this screen, which will remove just like this. Okay. Just like this, when the whole screen revolves, okay, the impurities which is attached on the screen gets removed. Okay. Now we will see how the screen works. Okay. We had installed one screen here. We have the two ways to install the screen. Now we will see the side view of the entire treatment unit. Okay. Now we have two options to install the screen. First one is either we will install the screen in a vertical manner, just like this. Now we had another choice to install the screen in this inclined manner. Now students, can you please tell me what is the correct way to install the screen? Now many of you thinks that we will install the screen in the vertical manner. Don't do that. Don't do that. Why? Because you know that Q is equals to AV. That is, the discharge is equals to area into velocity. Now, if we kept the discharge constant, then velocity is inversely proportional to area. Now, we all have a very good idea about the length of the inclined member is always greater than the length of the vertical member, because hypotenuse is always greater than the perpendicular. If the length of the inclined member is high as compared to the vertical member, so width is constant. So when we multiply the higher length with the width, the surface area of this screen gets increased. And when the surface area of that screen gets increased, its velocity gets reduced. And we are trying to reduce the velocity of that water before the screen. Why? To remove all the floating matters with higher efficiency. That's why we are going to reduce the velocity of that water before the screen. That's why we are always try to install the screen in the inclined manner at an angle of 30 to 60 degree. More generally, it will be installed at an angle of 45 degree. Now, the velocity of water before the screen is U and after the screen is V. Okay. Now we know that before the screen we had reduced the velocity, and the velocity before the screen is U, which is lesser than V. Now, if we have to find out the head loss, then we know that the velocity V is greater than the velocity U. Now, what is head loss? Suppose that this is the side view of particular treatment unit and this is the screen which is installed at an angle of 30 to 60 degree. Now, before the screen, the level of water is somewhere here. Okay. And after screening, the level of water will be just like this. Now the difference of two levels, that is the level before the screen and the level after the screen, is known as the head loss. Now we have to determine the value of head loss by this formula, that is 0.0729 V square minus U square. Now if the head loss value gets increased on a very higher side, then we have to do the servicing of that screen, means the cleaning of that screen is required. Otherwise, the complete void of that screen gets choked and the head loss value gets on increasing and the treatment unit stops working. Okay. So we have to do the maintenance or servicing of that screen. It means we have to clean that screen. Now, one note is written here, that is the velocity through screen should be less than 0.8 to 1 meter per second. It means that the value of u is generally kept less than 0.8 to 1 meter per second for the smooth functioning of that process. Okay. Now we will see the plane sedimentation tank process. Now, first of all, we have to discuss what are the impurities which we had already removed and what are the still removing impurities present in the water. Now, the already removed impurities are larger floating particles or floating matters which we had already removed in the screening process. Okay. We had also removed the color, taste and odor during the aeration process. Now we are going to remove the larger grit particles present in the water. Okay. Now you already had studied the fluid mechanics subject, and in that fluid mechanics subject, you had already studied one concept, that is the terminal settling velocity, or we can say that the terminal velocity. Now, how you had determined the terminal velocity? You have one beaker, you have one beaker just like this. Okay. And in this beaker, you had already filled some fluid here. Okay. And you had marked one point here and another point here. And the height of these 2 points, okay, or we can say that the difference of height between these 2 points, you already know that. Okay. Now, you have one stopwatch here. You have one stopwatch here. Just like this. Okay. Now, what you are going to do? You are going to drop one metallic ball from here. You are just going to drop one metallic ball from here whose diameter is already known to you. Okay. Now, when this metallic ball is dropped from this point, and when this metallic ball cross this point, you will just start the stopwatch. Okay, you will just start the stopwatch, and we will assume that after reaching this point, the metallic ball attains a constant velocity through which this ball moves in the downward direction. Okay. Now, when the ball reaches to this point, we have to stop the stopwatch. Okay. Now, the time taken by the ball to pass from this point to last point, we already know that. Okay. So, we have the time, we have the distance covered by that ball, that is the h. Now, we have to determine the velocity. Now, we all know that velocity is equals to what? Distance upon time. Okay. Now, we have the distance, that is the h, and we have the time, that is the t. So, this velocity is known as the terminal velocity. Now, we will define the terminal velocity. Terminal velocity is that constant velocity through which one particle moves in the downward direction in a particular fluid. Okay. Now, that is the concept of terminal velocity in fluid mechanics. Now, we are going to discuss that same concept from the environmental point of view. Okay, students? From the environmental point of view, how can we find the settling velocity of the particle? Suppose that we have one container here. We have one container here which is known as plane sedimentation tank. Okay, we will write it as plane sedimentation tank. Okay, plane sedimentation tank. Now, we will fill the water in which larger grit particles are present. Okay, and we will allow the water to remain there for at least 30 minutes. Now, what will happen during this 30 minutes? The grit particle which is present in this water, that is the larger grit particles, gets settled down due to its own weight, and the velocity which they will attain during this downward journey is known as nothing but the settling velocity, denoted by Vs. And this concept is exactly same as the concept of terminal velocity. So we can say that the settling velocity is exactly equals to the terminal velocity, and we know that the terminal velocity concept from the Stokes law. So the formula for the terminal settling velocity from the Stokes law is rho g d square upon 18 mu into g minus 1. So that is the formula of settling velocity of particle in case of plane sedimentation tank. Now we will write the entire sedimentation process here so that you can make the notes also. Okay. Now sedimentation is the settling of particles in the water due to particle size, specific gravity of particle, specific gravity of particle, viscosity of water, and acceleration due to gravity. Okay. So you had already seen in this formula, that is the density of water, the acceleration due to gravity, the particle size, that is diameter, the viscosity of the fluid, as well as the specific gravity. So we will write all the terminologies of this formula, where rho is the density of water, and if it is not given in the question, or if the value of that is not given in the question, then we have to assume it as 1000 kg per meter cube. Okay. G is the acceleration due to gravity. And its value is constant, that is 9.81 meter per second square. Okay, students. D is the diameter of particle, which will be in mm. Okay. Mu is the dynamic viscosity. Okay. Now you have to see the unit of this. Why? Because in question, generally they will give you the viscosity of water. They will not mention whether it is the dynamic viscosity or it is the kinematic viscosity. Okay. So you have to identify whether it is the dynamic viscosity or whether it is the kinematic viscosity based on the unit of that viscosity. Okay. So the unit of dynamic viscosity is Newton second per meter square or kg per meter second. Okay, students. Now, if they will give you the kinematic viscosity, that will be indicated by nu. It is known as kinematic viscosity. And it will be equals to mu by rho. And the unit of kinematic viscosity is meter square per second or centimeter square per second, and so on. Okay. G is the specific gravity, and it is unitless. Okay, it is unitless. So you had already find out the settling velocity of the particle. Okay, now we are going to see the sedimentation tank. Now this is the entire construction of sedimentation tank. On the bottom side of this, one hopper portion is shown here, but the size of this hopper portion is very small, so we will consider this entire tank as a rectangular tank. So we will consider the plane sedimentation tank as rectangular tank. Okay. The height of this rectangular tank is shown here, that is the height of rectangular tank. Okay, students, this will be the length of the rectangular tank, and width is shown on the depth of this screen. Okay, so it is not clearly visible here, but we will consider that the width is there also. Okay, so the volume of rectangular tank is length into width into height, that is LBH. Okay, now students, in this sedimentation tank, one baffle wall is shown here. Okay, one baffle wall is shown here. The functioning of that baffle wall is only to allow the water to strike on that wall and follow the downward journey. Why? Because if this baffle wall is not present here, then the entire water with the larger grit particle will directly move in the horizontal direction and reaches to the next treatment unit directly. So the particle will not get settled down here, and the larger grit particle is also not removed during this process. Okay, students. So we have to construct the baffle wall here just to restrict the movement, or to just restrict the horizontal movement of the water. Okay. Now, one conveyor belt is shown here on which flight scrapers is installed here. Now, what is the function of this flight scraper? We will see in detail. The movement of this conveyor belt is just like this. That will be in clockwise direction. Okay, students. Now, we are going to see the working of this plain sedimentation tank. Okay, students. Now we will consider that the water is moving from this direction and follow a downward journey. The impurities which is present in this water is the larger grit particle. Now when the water moves in this direction, impurity also moves similarly in that direction. Now all the impurities gets attached here with the flight scrapers. Now what flight scraper will do? This will just takes all the impurities. This will just take all the impurities along with it. Okay, along with it, and they will just try to move all the impurities in this direction, and they will just throw all the impurities here. Okay. Now, when this conveyor belt moves in the clockwise direction, during the downward movement of this flight scraper, they will just take all the impurities, and they will just take all the impurities just like this, and they will dispose all the impurities here. Now when the sufficient quantity of impurities disposed here, what we will do? We will just open this gate, and we will take all the impurities in the form of sludge from here, and we will dispose it by some other means. Okay, that is the removal of larger grit particle from this plain sedimentation tank. I think I had discussed that concept in a very detailed manner. If you have any doubt, feel free to ask here. Okay, students. Now that is the removal of larger grit particle. Now we have to see the mathematical terminologies of this plain sedimentation tank process. Okay, students. Now to derive the various formulas, we will see the two particles of, or two droplets of water. Suppose that one droplet of water is here and another droplet of water is here. Now we have to construct the sedimentation tank in such a manner that the time taken by the first particle is exactly same that the time taken by the second particle, that is T2. Okay, so time taken by the first particle is exactly same as the time taken by the second particle. Okay, now when the particle travels in the downward direction from the inlet point to the bottommost point, the velocity acquired by the flowing water is V naught. Okay, that is the velocity of water in the downward direction, not the velocity of the particle in the downward direction, because we already know that the velocity of the particle, that is the larger grit particle, during the sedimentation process is nothing but the settling velocity Vs. Okay, we had already determined that Vs will be equals to what? Rho g d square upon 18 mu. Okay, now here the downward velocity of the water is V naught. Similarly, the horizontal flow velocity of water in the horizontal direction is Vh, that is the horizontal velocity or the flow through velocity of water. Now we know that velocity is what? Distance upon time. So V naught will be equals to what? This will be h upon t1. Now if we consider this both the times as t, so we will write it as h upon t. That is the first equation. Okay, students. Now the second one is horizontal flow velocity or flow through velocity. Okay, so Vh will be equals to what? Length upon t2, or we can write it as length upon t. That is the second equation. Now we know that the time taken by the first particle is exactly same as the time taken by the second particle, that is T1 is equals to T2. So we will just do one thing. We will write the value of T from the first equation as H upon V naught, and we will write the value of T from the second equation, that is L upon VH. Now the time taken by both the particles is exactly same. So we will just equate these two equations and we will find the another equation, that is H upon V naught is equals to L upon VH, and that is the very important formula from the gate point of view. So this one is the very important formula from the gate point of view. Okay, students. Now we know that discharge will be equals to what? Discharge will be equals to what? Volume per unit time. Okay, volume upon time. Now from the concept of plane sedimentation, we know that the volume of the plane sedimentation tank is what? Length into width into height upon time. Okay. Now, if we will just see this value, that is length upon time. Now, length upon time is nothing but the horizontal flow velocity. So, we will write it as VH into B into H. So, from here, we will find the value of VH as Q upon B into H, and B into H is nothing but the cross-sectional area. So, we had find the another formula. We will write it as equation B. Okay, students. Now, if we will write Q equals to L into B into H upon T, and if we will consider this H upon T, we know that the H upon T value is nothing but the V naught, that is the overflow rate. Okay, overflow rate. So we will write it as L into B into V naught, and we know that length into width is nothing but the surface area. Surface area. So we will find the value of V naught as discharge upon surface area. And students, believe me, this is the most important formula from the environmental engineering. This is the most important formula. You will find this formula in the plane sedimentation tank. You will also use this formula in the filtration unit. You will also use this formula in the wastewater engineering. So this is the most important formula, that is V naught is equals to discharge upon surface area. Now students, we have the overflow rate of water, we have the horizontal flow through velocity of water, we know the settling velocity of the particle. Now, student, please tell me why we had constructed this plane sedimentation tank. What is the main idea behind the plane sedimentation tank construction? The basic aim of plane sedimentation tank is what? To remove the larger grit particle. Is it or not? Is it or not? So the basic aim of plane sedimentation tank is what? To remove the larger grit particle. So if we know from our common sense that what is the formula of efficiency of any treatment unit or any process, the formula of efficiency is output upon input into 100. Okay. Now, what is the output of this plane sedimentation tank? To remove the larger grit particle, and to remove the larger grit particle, what is the parameter shown here? That is the settling velocity of the particle. Now, what is the input in this plane sedimentation tank? The input is water. Now, the velocity or the parameter which will be there as the input unit of that plane sedimentation tank is V naught, that is the overflow rate of water, or the velocity through which water moves in the downward direction is V naught. So the formula of efficiency of the plane sedimentation tank is Vs upon V naught into 100. Now we had find all the formulas. The most important formula from the plane sedimentation tank is, the first one is efficiency of sedimentation tank, which will be Vs upon V naught into 100. The second one is overflow rate or V naught. Its formula is discharge upon surface area. Another formula is horizontal flow through velocity VH, which will be equals to what? Q upon B into H. Now these three are the most important formula from the plane sedimentation tank. Now we will write the terminologies of all this formula, where V naught is what? Overflow rate, loading rate, or superficial velocity, VH is what? Horizontal flow velocity. Horizontal flow velocity or flow through velocity. Flow through velocity. Q is what? We know the value of Q, that is the discharge. Okay. Now we had already studied the plane sedimentation process in most detailed manner. Okay. Now we are going to solve the numericals of plane sedimentation tank in our next session. That is all from the plane sedimentation tank. Students, to get a very good marks in your GATE exam, you have to cover these processes, because every time GATE had asked question from these portions. Okay, so you have to cover this portion very carefully, and you have to solve large number of numericals. Okay, or very good type of numericals from this portion. Okay, we will discuss some very good quality problem in our next lecture. For today's session, that will be more than enough for today's session. Okay, we will meet in the next session. Thank you everyone. Bye bye everyone.